many thousands of years, ceremonies have taken place on this country. Ceremonies that would welcome people to the country. Corroborees and ceremonies to celebrate the dreaming. In Aboriginal culture, country is more than just a word or a place. It's a feeling. It describes the entirety of the ancestral domains and holds the stories that continue to be told by the traditional custodians of the land. Stories of significance that have been passed down through the generations of Aboriginal people. Stories that continue to be shared to remind us of the rich Aboriginal culture that surrounds us. A better understanding and respect for Aboriginal culture develops an enriched appreciation of Australia's cultural heritage and is essential to the maturity of Australia and is fundamental to the development of an Australian identity. We would like to acknowledge the country and the traditional custodians of the land on which we are meeting today. We pay respect to the elders, past, present, and emerging, who guide our spiritual and learning journey, and extend that respect to all other Aboriginal and Torres Strait Islander people with us today.
Welcome everybody to today's webinar. My name is John Fennell from the International Copper Association. I'd like to thank you all for joining us, and I'd like to welcome our speaker. It's Joseph Daboul, who is an expert in telecommunications with over 40 years of experience. He's covering networking in both fixed and mobile formats. He's been a technical instructor for Telstra, for Milcom, NECA, and JB Hunter. Joseph will be presenting on this topic today. Also, welcome to Ian Milner, who's very involved in our industry with an enormous technical background as in education as well, after running and owning Milcom, and now working with the ICAA and your registrars. A special welcome and thank you to Julia Berklau from FPA, who's coordinating and managing this webinar for us today. And thank you also to all of your registrars, BCRA, ACRS, TITAB, ASIAL, and FPA for their support. Joseph is going to talk about how the Internet of Things is now dominating our world and how you have a key role in making it work better for your customers. Joseph is going to explain what's meant by IoT, what infrastructure is required, and the connectivity and protocols that you need to follow. As the CEO of the International Copper Association, I'm delighted with this topic because copper, of course, is the best connectivity conductor for communications and power. Joseph is going to talk for about 40 to 45 minutes, and then the floor is going to be open for Q&A. So if you do have any questions that come to mind during this webinar, if you look on the right-hand side of your screen, you'll see a column there, and right at the bottom you can ask a question and just send it. And that will log the questions and get to those at the end of today's session. Ian Milner will be doing that for us. So thanks again for joining us today, and over to Joseph. Hi, Joseph.
Hi, John. Thank you. And good afternoon, everybody. What we're about to cover today is a topic on IoT, or Internet of Things. Well, one of the things that come to mind is really the enormity of this topic. It's not, well, it can be simple and it can be very complicated. But what I'm going to try and do, I'm going to try to condense it in a way that it is presented in a sort of a understandable, simple sort of format. The first thing we're going to talk about is IoT itself, what it is, and what it does for us, and what role it plays in our lives. The other thing is we will be talking about the infrastructure required to establish an IoT system, and the connectivity and protocols, which is something that we will sort of discuss in a bit of details. And after that, we will open the stage for Q&A. So if you have any questions throughout, or you think of anything throughout the presentation, I would encourage you to note it down. And during the Q&A, you can ask your questions, and hopefully we will answer you. The first thing we're going to talk about is IoT. What is it? Defining the IoT is something, well, like we need to sort of, first of all, talk about what it is. Well, IoT is simply, if you can say it in a simple term, some gadgets that are able to talk to each other, that are able to talk to other gadgets. Well, I don't know, for those of you who've been in telecommunication for so many years, you would remember the days where communication was something about person talking to person. And for those of us who established a physical network like cabling system, all we had to do, if you could terminate a 50-pair cable, wow, you've done fantastic. Well, not anymore. Nowadays, it's a hell of a lot more advanced than this. It's no longer person talking to person. Nowadays, really, I don't know if people talk to people anymore. They talk more or less text each other. But it's more about computerized equipment or machines or devices talking to other machines, or people talking to machines, and that is IoT. So basically, it's a collection of devices connected for the purpose of monitoring, sensing, whatever these devices, they collect that information. The idea is to transfer that information to either another device or another processing center, analyze it, and make a decision. So IoT is simply used in many other types of systems. Let me just say, IoT systems can be either exist in residential, commercial, industrial, or simply urban architecture or infrastructure. The things we're going to talk about is the types of IoT infrastructure. Could be residential, like home automation, industrial, manufacturing, public services, like healthcare, transport, environmental monitoring, and energy management, or many other types. What is needed? Well, the systems that are needed or form a part of that IoT would be, one, the connectivity, and then the smart devices, data management, and the user interface, or generally application and user interface. The infrastructure required. Well, the infrastructure required for IoT things or devices would be, one, the gadgets, what we talked about, the gadgets, the controllers. You need network to connect them together. We need storage, so we can store and analyze and act on data, which takes place in either on the edge or in the cloud, and that is called a cloud or edge computing. And then we'll talk about the applications and user interfaces and what role they play. Devices and controllers. Most of us will probably know things about, like sensors, actuators, and other smart devices like, for example, temperature sensor or security camera. A lot of us in the communication industry, I know a lot of people in the security industry, they're very, very well familiar with that with that system. Smart TVs and many other smarter devices that play a role in that, where data is collected from an environment or even a user input, and that data then is communicated over the internet. And that's when it gets processed and a decision is made as a result. The network. Well, these devices, the IoT devices, need to be connected. Well, they have to have either a connection, either one-to-one or one-to-many. They need to have connectivity that allows them to connect over a local environment as well as over to the internet, depending entirely what type of IoT system it is, and dependent entirely on the size of it. So without network, these devices cannot do their job. So these devices can either come in one of two ways. They are either widely physically connected through a physical wire, that would be a wired connection, or for a smaller type devices, such as mobile phone, etc., well, they cannot connect physically through a cabled network, and then they will need a wireless network. Now, that information collected by these devices has to be processed. Well, it has to go somewhere. Well, so they need data storage. So these data storage can be either local that would be termed as either edge storage or local storage. Generally, edge or local storage would probably be used for a smaller, more like residential type infrastructure. However, larger type of infrastructure would be requiring something more larger scale type of storage and processing. That would be a cloud storage. Now, a cloud storage could be, we will talk about that separately, by the way. I'll expand on that a little bit more. Or you could have hybrid storage. Hybrid storage would be a combination of both. In other words, we can have local or edge as well as cloud storage. Cloud computing, edge computing, that's where the information processing takes place. So a cloud computing, for example, is, well, it can be a private or it can be public. Yeah. So, or it can be both. For that, yeah, connected to enable all devices to be connected to the internet and collect data from all these devices. And then it processes them and it provides actionable, well, basically it acts upon it. There's the information, do something with it, and then something happens. So that information is done at large data centers. Well, I mean, depends entirely whether the decision is made locally or made remotely and they're relayed back. That depends entirely on the type of infrastructure used, how small or how large it is. While edge computing, it's more likely to be used by a smaller type of infrastructure. So where the information is in fact sent and stored on a local device, like a NAS drive, hard drive, external hard drive, internal hard drive, what have you, or even on something like a flash drive. Edge computing has its advantages in the fact that it is fast, where in fact you could make a decision in real time, while cloud computing may not be as fast, but it has a lot more a lot more advantages in terms of capacity and, more importantly, security. User interface. Well, in order for a user to interact with these devices, you need an interface. That interface could be actually that's an API, type of API, a type of API where it allows a person communicating with a device, and that would be a user interface. The user interface allows that person to load an application. That application could be either a proprietary custom application or could be an open standard type of application where you can load it on a device and you can, for example, monitor a CCTV system, and you can also manage a device. So it can be used for both, either monitoring purposes, management purposes, or simply making decision purposes. So through that interface, like mobile apps, for example, through the user interface, the user can engage with the Internet of Things system, through that interface, and they can either view the data and also remotely or directly can interact with the device and do something. Applications. Well, these applications allow the number of, they sort of play a number of roles. One of these roles is, in fact, to allow these smart devices, whether it is smart homes, industrial automation, or whatever. So it enables them to communicate amongst each other or simply communicate with other. Well, the first thing it does, or it allows these devices to do, is connect to a device. So the other thing it can do is it enables them, those applications enables them to, in fact, give them the intelligence to collect information, and following that, transfer that information, collected by a sensor, for example, to either a local device or local processing system to make a decision, and then something happens. For example, temperature gets too high, stop the air conditioner or goes on idle until the temperature drops, and then sends temperature low, and then we go off again. Sensors, actuators, and other smart devices are examples of physical devices. So these have embedded applications. These embedded applications, they form some type of a protocol, which allows them to communicate at a physical layer. And that would be something like a short distance wireless connectivity like Bluetooth or Zigbee or Wi-Fi. Zigbee is another Wi-Fi and another Wi-Fi technology used for low power, low cost type of devices, and they only operate at 2.4 gig. Wi-Fi, however, Zigbee, I believe, mostly will provide only one-to-one type of connectivity like Bluetooth, while Wi-Fi can provide a point to multi-point connectivity. So these can either be connected through a gateway, or they can be connected to each other directly through these applications. That also allows them to gather information. So all IoT smart devices, through sensors and whatever, they gather the data, they gather the information, they collect the data, and from their environment, like temperature, humidity, motion, etc., motion detection, whatever you, and then after that, the device itself can process the data locally, or simply even send it locally, or can send it to the cloud to be processed, dependent entirely on the type of IoT architecture. So the IoT apps can also, you see, they allow, as we said, they allow data to be collected by the sensors. So these communication protocols like MQTT, CoAP, or HTTP is the larger one. But the other two, they are simply sort of they cannot work on their own independently. They actually have to work on top of a communication or a transport protocol. MQTT, for example, is a basic protocol that is used to allow a device to talk to another device, while CoAP is similar to MQTT, but it's generally designed or sort of intended for smaller type devices like battery operated or low power type devices. So these do allow the transfer the data from the device to the cloud or simply to another device. So the processing, analyzing the data in the cloud. Well, the cloud generally would be more like a big data center, generally for perhaps a large scale IoT infrastructure. So the cloud then examines and evaluates the incoming data, and then these services, what it can do, it can store, process, and analyze that data gathered in the cloud for the purpose of number of things. One of them is to provide a decision, and actionable decision, which leads us to making the decision. After all of that, a decision is made. So after we've done all of this, and then what we do, these applications will establish a rule and a logic to make a decision in real time, based on the analysis, of course. So these choices may result in, say, for example, an alarm being sent, or device setting being changed, like we said about the temperature, start, stop, or other automated procedures being started, like start a machine, start a motor, shut the door, whatever you, or things like this. These are some automated functions. The connectivity and the protocols. For connectivity, we're going to need, say, either a wired infrastructure or a wireless infrastructure. And then we will also talk about the protocols used over that infrastructure. The first type of connectivity is a local area network. Most of us know it as a LAN, which is known as our perhaps as a definition. Two or more devices connected together over a small, predetermined sort of a geographical area. Generally, it's local. It can be wireless, or it can be mostly wired, yeah, but it also can incorporate wireless as well. While the LAN devices provide the connectivity, well, you need cable and we need devices. These devices, like, for example, an Ethernet switch, router, or a Wi-Fi access point. Sometimes you can get in residential, for example, rather than these being discrete components, they can come into an integrated device, like people call it router, people call it modem, people call it multifunction device, which is a gateway. The switch generally switches are the most common network connectivity using Ethernet, of course. Ethernet happens to be one of the most popular communication protocol ever used, basically it's for both, whether it is local network or even remote networking. Not only that, it can provide power to devices over the Ethernet copper cable. Yeah. So while wireless, however, it has it has advantages, and the advantages is it doesn't need a lot of work and it doesn't cost as much to actually establish a physical infrastructure. And not only that, you don't need registration you don't need cables, in other words. However, though, the disadvantages is every device must have their own independent power source. And that, for whether it is wireless or fiber connected device, must have their own independent power source. Let's look first at the wired LAN network, which is a twisted pair. Most of us in the cabling industry, we know it as structured cabling. The structured cabling, most common copper cable for this type of network is either Cat6, now becomes the most common entry-level type of category for structured cabling. Cat6A or Cat7. I mean, there is another category called Cat8. I'm not sure if we even have it in Australia yet, but anyway, it does exist. No matter which one of these is used, the maximum distance is 90 meters. That 90 meters is specific to a fixed link, and it's called the permanent link. Excuse me. It can be extended to 100 meters through attached leads or on both sides. And then that would become a channel. And that would be about the maximum distance that infrastructure can work on. It's really suited for power over Ethernet. So in other words, every device can be powered over the Ethernet cable. It can also provide bandwidth, a great carrying capacity, something like, for Cat6, for example, 250 megahertz. Cat6A can do you something like 500 megahertz, while it can also go up to 10 gigabits per second. And the Cat7 can do up to 1 gigahertz. And I believe it can also go up to, not only do 10 gig, it can also get towards 40 gig. But unfortunately, the distance will come down to about 30 meters. There is actually new technology coming on the market. Well, it's not commercially available yet, but the ability to, in fact, to transmit Ethernet over just a single pair. See, so this is at the moment it's in the development stage. So that supports transmission rates of up to 10 meg. Sorry, from 10 meg up to say a gig. And the cable length can in fact extend up to 1 kilometer. That would be great, and it'll have its applications, of course. Fiber. Well, I'm not going to talk about the fiber now. I'm going to leave that, and I'll talk about the fiber in a separate slide. A lot of us cablers are, I would say, familiar with fiber. In order to do fiber or to run fiber cable the same as the structured cabling, the copper UTP cables, Cat6, Cat7, etc. You must have an open license with endorsement for fiber cabling, structured cabling, or coax cabling. These are mandatory in order to legally be able to work on these cables. So fiber cable is generally in most cases in a network and used as a backbone, especially in a larger network. Yeah, it can be either a multi-mode or a single mode. Now, a multi-mode, well, in the earlier days, it couldn't do any more than 100 megabits per second. And that would have been OM1, and that would have been able to sort of accommodate distances up to 2 kilometers. But unfortunately, 100 megabits per second is not exactly adequate anymore these days. So we needed something like about a gig or above. So then we had to go to OM1, OM2, OM3, I think was able to do a gig. OM4 and OM5, they sort of increased the bandwidth. They were able to do 10 gig or even 40 gig, but the distance shrunk down to about 500 or 300 meters. And there's a problem with that. Multi-mode cannot handle high frequency without. See, what's happening is with multi-mode, attenuation at high frequency is terrible. In other words, you cannot go the high frequency for long distance. It simply won't survive. Unlike single mode. Single mode, the attenuation rate is equal on both, whether it is low frequency or high frequency. So in other words, they attenuate evenly. And that's the thing with single mode. It's able to carry not only low capacity, also high capacity at greater distances. A minimum example, 1 gig at minimum of 10 kilometers, for example. However, though, with fiber, unlike copper can do analog, can do digital. Fiber cannot. Fiber can only do digital, and it can only do light, as in optical signal. In other words, all electrical signals have to be converted first to digital and then converted to light in order to be transmitted over that fiber network. Wireless LAN. Well, if you can't have a structured cable system infrastructure, And then you're going to need a wireless, if you don't have cable, and then you need no cable, and that's called wireless. One of the most common wireless technology used these days is Wi-Fi. Wi-Fi, which initially in the earlier days, Wi-Fi was invented or developed by a couple of Australian scientists, and it was point to point, and they called it short distance microwave. But over the years, it got developed by, I believe, the Americans. They developed it into a technology where it became a point to multi-point technology, starting with 802.11b. Well, these are the earlier, they ran at 2.4 gigahertz, and the bandwidth wasn't really all that great. When we've gone to G and N standards, we were able to achieve something like 450 megabits per second. That would be sort of on a typical top speed, yeah? And the distances, by the way, that depends entirely on the distance as well, and the environment, because you cannot really put an exact figure on a Wi-Fi performance, because the Wi-Fi performance depends entirely on a number of factors. One of them, the environment, yeah. The other thing is the distance. Now, the new technology or this Wi-Fi standard that came up with Wi-Fi, the fifth generation. The fifth generation used the same standard, 802.11, but it's AC. And that ran at 5 gigahertz. The beauty about this is, unlike the 2.4, it is not affected by interference from other devices in the near location, where they're like such as microwave oven, for example, which operates at the 2.4 gig. Well, the 5 gig doesn't get affected by that. So not only that, the other benefit is that it has much greater bandwidth. So therefore, it can provide speeds of up to 6.9 gigabits per second. Fantastic. That would be great if you cannot look. Quite frankly, most IoT devices we're talking residential, they don't need any more than 2.4 gigahertz. In fact, a lot of them do not even support 5 gig. They only support 2.4 gigahertz, like Zigbee devices, for example. They only support 2.4 gigahertz, which is good because they don't really need to transmit a great capacity of information. The 5 gig or the AC standard is generally great for perhaps maybe smart TV, streaming, video contents, 4K, for example. Over 5 gig will obviously over a reasonable distance, it can give you good results, while 2.4 gig cannot really do it adequately. Wi-Fi 6, which is something has been available, I believe. I haven't seen one myself, but it is in fact available, technology commercially available, and it can, in fact, this is called or labeled as 802.11ax standard. Yeah, that's the IEEE standard. It can, in fact, have carrying capacity of much greater than 7 gigahertz. 7 gigabits, sorry, I should say. 7 gigabits per second. The other technology that is suited for really shorter distances, low capacity, short distance, like Bluetooth. We all know what Bluetooth is. It allows allows devices to connect to another device over a short distance. That short distance can be somewhere up to no more than about 10 meters. It can actually provide a point-to-point or point-to-multipoint in some cases. Some devices used generally in mobile devices, laptops, smart TVs, and basic short distance type of communication. Another wireless communication is called NFC, or near field communication. Your mobile has an interface for that, where you have your tap and go, your fobs. It's big in the security industry, especially in access control, where you use fobs, near field communication, to open doors, let you in, open gates, etc. WAN. A wide area network is a collection of LANs. A definition of a WAN is two or more. If you have two LANs connected together over some larger geographical area. How large that geographical area? I don't know. It's undefined geographical area. Nowadays, most of our WANs actually connect to the internet. So where you have a LAN, whether it is home, office, large commercial site, industrial site, and they're connected to the internet. And they're connected to the internet through through routers. You have a router is a WAN device, unlike the switch, which is a LAN device. A router enables, just like an exchange, allows data to flow from a private location to through a public domain to another public location, like the internet, for example. Yeah. So WANs provides connectivity. The connectivity for WAN could be wired or could be wireless. For example, wired connectivity can be fiber or copper, like NBN. NBN has what they called the multi-technology mix, which includes fiber to the premises, or FTTP, fiber to the node, FTTN, fiber to the building, FTTB, or fiber to code, FTTC or HFC. There are so many of them that just you get lost with these things. Anyway, other than that, there is wireless connectivity. The wireless technologies used for that would be the mobile network, 4G, 5G. Yeah. Not only that, NBN actually uses a wireless technology as well, but it is not the mobile type. In other words, it does not allow roaming. It is fixed. LANs and protocols. Well, LAN protocol, well. There's a lot to talk about this, but I'm not going to go to that in a lot of details. All I'm going to say to you is this. LAN protocols and WAN protocols are almost the same in terms of, one, physical connectivity protocols like Ethernet. That's communication protocol. And it's used for both LANs and WANs in many cases. Yeah. However, then we go to upper or higher level type of protocols like common internet protocols like TCP/IP. These are referred to as transport protocols. Amongst all of that, right, and on top of that, and then you have the IoT applications and protocols, which can be open standard or proprietary standards. Yeah, they actually utilize these common protocols in order to transfer information from one point to another. But the underlying protocols for LAN is Ethernet, TCP/IP. For WAN, it can be other technologies for lower, but nowadays it's becoming Ethernet. Now Ethernet is over fiber. It's actually Ethernet converted to light, and it's transmitted over fiber. And then on top of that, you have the application layers, as in the upper layers. The upper layers would be carrying the transport protocols, such as TCP/IP, that will allow devices to communicate with each other, as well as communicate with the internet and the cloud. Okay, these are some of the links that you can refer to. And the last thing we're going to do, I'm going to leave you now with the questions and answers. Thank you.
Hi all, thanks Joseph for that presentation. And obviously there are some comments and questions on the Q&A session. Just to mention, Alan, for example, has talked about the fact that he understands that in agriculture there are, significant use, particularly overseas, of radio connectivity, and there are a plethora, by the way, of different protocols that are being worked on and developed. The focus here is more on what we need to do as cablers. So, and obviously, as he mentions that, a lot of these, LoRaWAN and Sigfox are moving into, sort of Wi-Fi, becoming more and more extended. Graham, this is there. I said a designated IoT WRAN band for 4G LTE or 5G systems. I'm not aware of that, Graham. Joseph, you any sort of thoughts on that?
I'm sorry, well, can you repeat that again, please?
Is there a designated IoT WAN band like 4G LTE or 5G NR? And I'm not sure. I'm not enough across that, to be honest. But again, I reiterate when we're talking about the IoT, the connectivity, obviously, from a focal point of view for us is the cabling, which is absolutely critical. So
yeah,
and also the cabling within the residential premises, because we are talking about registered cablers in particular. So so it's interesting. One question here is I'm being asked to turn the printer into an IoT and remove it from a normal network access. Their application situations. One of the other common themes here is, someone asked a question, and what I'm saying is to clarify is could you consider an alarm system an IoT system?
Not really, not necessarily, no. An IoT, an alarm system generally is fairly closed system.
But you could connect.
You could, yeah, of course you can. Of course you can. You can turn it, but in order for, not all alarm can support an IoT connectivity, because in order to do that, you will need an Ethernet. It has to support IP, as simple as that.
Yeah. So only
any device that can't support IP is not an IoT system. Sorry, let me rephrase that. Any device that cannot support IP or TCP/IP cannot be an IoT system, IoT device.
Right. Now, how does a smart TV form part of an IoT system?
Well, a smart device. Well, you can use it. You can. How does it?
My take on it, and if you bear with me, Joseph, is I find this is the thing about IoT, is that and you said it right at the beginning, Joseph, it's actually a very broad topic at one
Very,
level.
extremely broad.
Let me stop for 1 minute, which is what we're trying to do is tell you the infrastructure required is structured cabling, LAN, WAN interfaces, and obviously the engineering to ensure that that systems deliver.
Mhm.
But a smart TV is actually a device that actually collects data, that is, you requesting information, you making decisions, that then gets collected by in a data center under cloud computing, which can then be used to actually serve you with information or sorry, suggestions of what you want to watch next, with obviously necessarily commercial backup for someone to make money. That then gets connected with the other big interface you have, which is called your mobile phone, or your when you're using Siri or Google or Alexa. Every one of those are a sensor for an IoT system, which is in an essence controlled by the large companies that are collecting data and then servicing stuff that they think is best suited for you. So
Exactly.
that
Like streaming
that's
services.
the complexity
Like
of
streaming services.
IoT system. Okay.
Yeah.
What power standards for IoT devices do cablers need to be aware of? It's primarily, I would say, the PoE standards.
Two things. One, a cable structured cabling infrastructure must be built to a standard, which is the 11801.
Yep.
The 11801 says that the cable has to be no more fixed between two endpoints, and it cannot be any more than 90 meters. It has to be tested. Now, dependent entirely on whether the test is verification test or certification test. Generally, in most cases, the standard, we're talking about regulatory standard as well as technical standard, would call for a certification. That's regulatory standard. So in other words, it is required by law. In order to certify a cable, you have to not look. I know because I come across a lot of people who come to the course telling me stories about doing cabling. Now I don't know how they do the cabling without registration. I guess under supervision, and I'll leave it at that. However, though, what do you use for tester? Oh, they use light, the wire mapper. Well, wire mapper is not a test.
Yeah.
It's not a test. You've got to use the proper test. In other words, you have to use a certifier. And you have to certify it. In order to certify it, it has to pass over the entire frequency spectrum, not part of it, the entire frequency spectrum.
Now,
in other words, unlike Cat5e, Cat5e would only have to survive 100 megahertz of spectrum, while Cat6, 250 megahertz of spectrum.
Yeah, and can I just say, by the way, I should mention that was recently brought to my attention, and it's probably worthwhile for the guys that are listening to this, that there is some companies selling what they call CCA, structured twisted pair cable, which is copper cladded aluminium. Okay.
Oh, okay, yeah.
You cannot use any aluminium cabling in a structured cabling system because it does not comply with standards. So if you are buying any cabling, please be aware of that. That came through to me probably about 2 or 3 weeks ago.
How do you terminate an aluminium cable on a copper block?
No. It looks and feels like a twisted pair cable. It's got all the signs saying that it's supposed to be Cat 5, 6, whatever certification, but it is copper clad aluminium. And if you install that, I guarantee you'll be back there replacing it because you cannot meet the resistance requirements for Cat structured cabling, in particular when deploying PoE. So be absolutely careful what you provide. Okay.
Aluminium has 1.5 times the resistance of a copper.
Yeah. Yeah. So just beware of that. The other thing is can you install and this, by the way, it's a question that actually has come up with some of the inspections I've done for NECA and in some of the work that I've done for them, which is can you have systems where IoT uses more than 100 meters of copper? Now, I'm going to answer this because you can provide a customer anything they want as long as they realize what they're getting. If you're doing structured cabling, which is generic cabling, which anyone can use because it's 90 meters to a maximum of 100 meters between the permanent link and the channel, okay, it's perfect. There are CCTV applications, for example, where you can have cameras that are installed with 200-meter cable lengths, but then those are proprietary protocols. So therefore, if you then change the infrastructure or change the cameras, you would then have to replace those with ones that were also certified to be running over longer distances. So there are proprietary solutions that are sometimes used by companies, and there's nothing stopping you from doing that, just so you're aware.
That would, in everybody, that would not be classified as structured cabling.
Correct.
Why? Because it does not comply with the ISO 11801. It doesn't. So if it doesn't comply, it's not a structured cabling.
Yeah. So just beware. It's just that they do come up. And there's nothing wrong with, by the way, providing solutions. Again, if your customer requires something, it is still at a level and part of an IoT system. The key here is that when you're providing the infrastructure you're providing has to be generic infrastructure, so that when someone comes to use it, they don't end up, why isn't this, with a situation, why doesn't this work? Because you decided to put 150-meter long lengths of cable. Okay, so I just keep that in mind when you are doing work for someone. So the other comment that comment from Ibrahim is he reckons that the biggest issue with the hurdle towards IoT devices is the lack of support in terms of certain protocols such as 802.1x authentication that our network relies on, and I agree. This is a developing area, by the way.
That's the Wi-Fi 6.
Yeah. So and then of course his other comment is we're very much at the sort of at the growing stage of IoT. There's a lot of elements here, but just beware. The IoT is anything that collects data from anywhere can then be stored somewhere, and then that can be combined with data sources from other places to then take actions. Okay, and the biggest example is what Facebook and Google and Alexa and those guys are doing. They're collecting data on us, which they're then going to use to try and make us obviously spend more money. That is an IoT system at work at a very large level. So I have no other questions at this moment.
All right, so Ian, thank you. We might start to wind up there. You've got the timing absolutely perfect, Ian and Joseph. Thank you, and thank you, Joseph. That was excellent.
Thank you very much.
Explanation, and thank you, Ian, for corralling all of the questions for everybody, and thank you all for joining us today. Our next webinar is going to be held later in February 2025. And we'll put the webinar details, up on and video up on our Registered Cabler website, which is on your screen. It's www.registeredcablers.com.au. This website, by the way, is attracting over 3,500 of your customers every month, and it would make sense for you to have a look at that and to promote your business. Because it's going to beef up your revenue as it's doing for the people that are already signed up on it. We look forward to seeing you again in February, and thank you very much for joining us today. So over to Julia to close down the recording. And thank you again, Ian and Joseph.